Welcome back to the 6 Caillou series. This is called highest scoring word. Given a string of words, you need to find the highest scoring word. Each letter of a word scores points according to its position in the alphabet. A equals 1, B equals 2, C equals 3, etc. You need to return the highest scoring word as a string. If two words score the same, return the word that appears earliest in the original string. All letters will be lowercase and all inputs will be valid. Okay, so that's pretty straightforward, right? Number the letters 1 to 26. That's their point value. String's going to contain a number of words separated by a space character. They say they'll be all lowercase. You can trust that, or you can sort of cleanse the input yourself. So go ahead and pause the video and get started. Come on back when you're ready. Okay, we'll go into it. I'm going to use some LINQ convenience methods, and then if you want to stick around, I'll do it without LINQ. So to that end, using system LINQ. I know I'm going to use it for one solution. All right, so one thing we can do, if you don't want to believe them, you can say string input equals s, and remember string has this toLower method. This will ensure that all input is lowercase. And I should say that my strategy for solving this problem is going to be similar to some techniques we've used in previous videos. I'm going to use the ASCII table, right? Do you remember I showed you that before? It's over here. Each keyboard character has an underlying integer value. So if you notice lowercase a, we're not dealing with uppercase, right? We made sure everything was lowercase and they said everything would be. But you'll notice A is 97, lowercase b is 98, C is 99, right? And so I can sort of get to the point value by subtracting an offset value from this, right? If I want A to be 1, how do I transform 97 to 1? Well, you minus 96 from it, right? Subtract. You'll notice if you do that from each value, 98 minus 96, you get 2 for B, 3 for C, 4 for D, etc. So that's how I'm going to do it. You could alternatively build some kind of dictionary with key value pairs that are a character and an integer value, and so you could populate that dictionary with the character A and the value 1, the character B with the value 2, etc. for the others. It's just a bunch of extra work that I don't need to do here because of how simple the scoring system is. Just to give you a heads up, I noticed a later challenge that had to do with scoring Scrabble words, and I'm sure we'll get to that. You know, I figured I'd start with this one as a more simpler example, and then, you know, you build on that. So then we'll look at deriving points in a different way. But for now, I can sort of leverage these ASCII values to get that. So I'm going to make a static private variable to hold that offset value, and I like doing that because we've talked about magic numbers. Now I can just throw 96 around in my code, but you know, I didn't memorize that lowercase a was 97. You know, I would look at code and see 96 and not necessarily know what was going on. So try to be expressive. Static read only. It's like a constant. We don't need to change the value. And I'll say ASCII to points offset, and I'll make it equal to 96. And now I can use this name, and that's a lot more expressive for people who come behind me and have to work with my code. They have a much better idea of what I'm doing. So anyway, we got the input. We enforced the lowercase, even though it should be. Let's split the input. We'll say, because we want a collection of words that are sort of competing against each other for the max value, right? And so you've seen this before. You can say split on a string, right? And you provided the character that you want to split on. And they didn't mention this, I think, in the instructions, but they are separated by a space character. And if you weren't sure of that, you could go through the input, just write a console write line, output, input is, and then the value of s, and you can see what kind of things you're getting in there. It should also be clear in the tests too, so you could scroll down and say, here you go. See, it's all separated by space characters. So that's why I put this single space thing in there. Now in real life, do you have to worry about tabs and other kinds of white space? Maybe you do. Here I didn't. So, okay, good. So at this point we have a collection of words, right? And we want to score them. And the way I'm going to do this is, I already hinted that I'm going to use LINQ, and I am. But instead of using a lambda, I'm going to just write out a little helper method to do this. So private static int, because I'm going to, here I'll just give you the name of the method. Let's call it get points for word. And it will take a string, I'll call it word. And the idea here is that I can inject any of the words in this collection into this method and find out what its points are, and you can probably see how that would be handy for solving this problem. So that's in general kind of what I do when I tackle these problems. You think, oh man, wouldn't it be nice if there was some method that does this? And then you can sort of solve the problem at a high level if you had all these nice methods. Well, make those methods and then you can do exactly that. So anyways, int points will start at 0, right? And we'll calculate for each character, for each char ch in word. And we can say points plus equals, right? We're going to add. And so what do I want to do? Do you remember when we got the ASCII values in previous challenges? I can do that by casting the character into an integer. And so it just sort of interprets its integer representation, and you get that ASCII value here. So points, add the ASCII value to it, but not quite, right? We don't want 97 for A, right? We want to say the ASCII value minus our offset here. We want to take that 97 minus 96 to get the 1 point for an A. And then finally, once you've gone through all the characters and added its point value, you can return your points. Good. So now we got this nice helper here. I'm going to copy it because we're going to use it. So let's get into our LINQ now. We have words, and I'm going to use a new method that I don't think we've used yet, but it's very similar. You've heard of max. We've used max to get the largest element in a collection, and it usually happens with integral values, right? Where it's sort of, it's clear for the system to rank, to order integers, right, in order. And it might do that with words too by default, but maybe it's alphabetical comparison. We specifically want this custom point system for a word, so we're going to have to tell it to do that. And if you go, MaxBy is what we're going to use. Remember, this is under enumerable. I'm telling you, you might as well just have one tab open with enumerable while you're learning, and you can have all these methods right here. And all I did was go to MaxBy. Sorry about that, I clicked there. Let's go back. MaxBy. So it's a little bit different than max. Basically, you give it a function, a lambda will pass to it, and it just says how to get a point value for each word, and then that will allow this max, this special variation of max, to return the word itself. We don't care about the point value for the word, right? Look at what we're returning here. A string, right? They want the actual word, not the point value. So MaxBy is good for that. I did find this other little article. If you wanted to read about it, might be helpful for you if you're looking for the difference kind of between max and MaxBy. ExceptionNotFound.net is the website, and they had a good example here. Like, this is what we're used to, right? You got some numbers, you just hit max, and it just knows what to do with the numbers. But hey, now you're not a noob anymore, and you're working with real data, and you've got these custom user classes, right? What does it mean to be a max user? Is that the person who's the oldest, the smartest, the strongest, you know, whatever. And so you can use MaxBy on this group of users, and you can just say, hey, yeah, take the user and determine its max based on some property it has, right? Because all these had a date of birth, and you can use the year value, right? So that's kind of cool, and you could do it off different properties. So we're using the same kind of tactic there. So we can hit MaxBy, and so I'm going to set up that lambda. I'm just going to call our parameter word. You know, it's for each element in words. I think word is a pretty good name for that. And then we can say, let's see if I still have that copied. I do. Get points for word, right? And so this should give us the max word value. And let me see if I did things okay. Cannot implicitly convert type on line 8, string array to string. Sure, right? Like split, what does it return? It returns an array. Should be in words. That's what we were expecting here, a collection, right? We don't want just one string. That was the problem to start with. They gave us all in one string. We want individual words, so good. Okay, green and green. So yeah, you could stop here. I'll do it without LINQ. You don't need LINQ. I just want to hammer that point home. It's supposed to be a convenience, but you can do any of this stuff on your own. And if you're not comfortable doing it on your own, stick around and or even if you're not sure, just stick around and we'll do it without LINQ too. But I just want you to know, as we get higher in the Caillou level, I'll probably stop doing some of this stuff where I really spell it out by the numbers. So note that you could do this. You can just say string lower, right? And you can imagine I can keep chaining this, right? So instead of words, I can do put that in. All of a sudden you don't need this. And you know, I think this is still pretty readable. I'll leave that up to you to be the judge too, if you think I'm trying to be too much of a hipster here, a one-line Wally or not, but this should be the same thing. I think it's very readable and it's not forced and overdone, so I'll end up submitting mine this way. Let's comment that out, and then I'll say string away words equals s split. Notice I didn't do the two lower here, but that's fine. This is just the extra to show you you don't need LINQ. So you have a bunch of words, right? We can set up a variable to hold the max value we find, and we can set up an integer to hold the max score that we encounter at any given time. We'll start at 0. All the letters have positive values, so 0 will be any word we find will beat 0, so that should be okay. Then you can say for each string word in words, right? And you could go in score equals, oops, I thought I still had get score, get points for word, and you can put word in there, right? And then you can check, you can say, hey, if the score is greater than max score, which it will be the first time, what do? Well, you update max score, you found a new max, and you set your word, max equals word. And the idea is when you've gone through the whole loop, checked every word, you simply return the max. And this should do the same thing. Let's check it out. Yeah, who needs LINQ, right? So yeah, there it is without LINQ if you wanted it. Again, you didn't need to write out this whole method. I thought it was cleaner that way than trying to cram all this into a lambda statement. Some people really like to do that. not such a big deal to me. I like them when they're short and I can fit them on one line especially. Sometimes I'll go a few lines, that's fine. But I'm going to go back to my other solution. Again, I thought it was clean. It wasn't hard to understand. You didn't have to scroll across the page to get to it. So I'm just Control Z to undo everything I typed for that last example. And I'll make sure this still runs. And where are we at? There we go. Okay, yeah, so we are clear for takeoff. I'm going to leave it like this. I like not using the magic number. That's easy. And, you know, another quick point, you know, could I have used a magic number and then written a comment, right? Instead of here, I could have put 96 and then add a comment, see ASCII table, or, you know, however you want to describe how you're offsetting its ASCII value, right? And so that's okay. But if I can, or I would recommend if you can be expressive with the actual code you write, that's more powerful. The idea is that comments can be good, but they also have to be maintained, you know, or maybe not most of them, but they can go stale. And, you know, hopefully people, when they update the methods, are updating the comments with it. If not, then it starts to look confusing and weird. So yeah, just skip the clutter altogether. If you can really name your variables well, your methods well, then you don't have to read a comment and then sort of apply it to something that's more cryptic and do this extra mental gymnastics in your head. To me, that's an inferior approach, but your mileage may vary. That's how I roll. So I'll go ahead and they're going to make me run this again. And yeah, I don't want the 96 there. There we go. I don't like the magic number. So submit, get your points. Look at other solutions. And yeah, there you go. Nice. Nice and short. See, magic number, bam. That's okay. I don't like it, but a lot of other people do. And so, yeah. Yeah, they just wrote out the alphabet and then used its index in that string as sort of the point value. That's okay. I like ours better, but yeah, see what else you can learn. Hit me up with questions, show me your solutions, bring on the comments. Otherwise, let's keep learning. Thanks for watching.